Uber serves over 150 millions of reads per second. At core, it is Uber's doc store, a MySQL-backed, globally replicated document store designed for simple key-value access at massive scale. But serving every read from doc store creates huge read implications and high tail latency. So Uber built cachefront, a distributed caching layer using Redis cluster, sitting directly in front of doc store. Every request hits the cachefront first. If it is a cache hit, it is served instantly from the memory. If it is a cache miss, it is fetched from the doc store. This alone scaled Uber to around 40 million reads per second. But the real challenge was consistency and resiliency. Uber didn't just add a cache, they built an integrated cache system. They used coordinated cache invalidation using Flux to keep cache and database in sync, achieving around 99.9% consistency. They added a negative caching to avoid repeated database hits for non existent data. They implemented cache swarming across regions by replicating keys instead of values to avoid inconsistencies during failover. They sharded Redis across multiple clusters to handle massive scale and prevent hot partitions. They added circuit breakers to skip failing Redis nodes and protect the database from overload. They even used adaptive timers to balance latency and cache efficiency dynamically. And to validate correctness, they built compare cache system that continuously checks cache versus database mismatches. With all of this combined, Uber scaled from 40 million to over 150 million reads per second. Caching is not just Redis in front of database, it's replication, invalidation, sharding, failover, and deep integration with your storage layer. If you want to read the full vlog, comment Uber, I'll send them to your DMs.